Hello and welcome to today's lesson on changes in internal energy, which is part of the particle model of matter topic for GCSE Separate Science Physics. So in today's lesson we're going to look to see how we can calculate the change in the internal energy of a substance. So if we're successful and we learn in today's lesson, we can observe how the internal energy of a system can be changed. We can describe how a substance can change internal energy, and finally we can calculate the change in the internal energy of a substance. So this falls into the following part of the GCSE AQA Separate Science specification. We're looking at temperature changes in a system and specific heat capacity, and we're also looking at specific latent heat. Now, previously we've considered how to calculate the internal energy of an object. So internal energy is the kinetic energy of all of the particles plus the potential energy of all the particles. Now remember, this is a summation of all of the particles in the object. Now the kinetic energy store is due to the movement of the particles. The potential energy store is due to the intermolecular forces of attraction between the particles. Now we can't calculate the total internal energy of a substance easily, but what we can calculate is the change in the internal energy of a substance. So we can calculate the change in the kinetic energy store of all the particles by looking at the specific heat capacity of a substance, while we can calculate the change in the potential energy of all the particles by looking at the specific latent heat of the substance. So in today's lesson we're going to look at calculating the increase or decrease in internal energy, but not the total internal energy. Now we can work out the change in the kinetic energy store and the change in the potential energy store with two different equations. Now what happens is these values can be added together to work out the total change in the internal energy of the substance. Now we can define the equations for the two energy stores using the definitions for specific heat capacity and specific latent heat. Now the specific heat capacity of a substance is the energy needed to raise the temperature of 1 kilogram of the substance by 1 degree Celsius, whilst the specific latent heat is the energy needed to change the state of 1 kilogram with no temperature change. Now, this is an extremely important idea because previously we've considered this in terms of the heating curve and the cooling curve. Now we can identify the state change or the change of temperature from a heating curve or from a cooling curve. Now we can calculate the energy needed to change state with the specific latent heat equation, and we can calculate the energy needed to change temperature with the specific heat capacity equation. So you can either have a change in the kinetic energy store, which is governed by the specific heat capacity, and you can have a change in the potential energy store, which is governed by the specific latent heat. So it's very important that we can place the equations for specific heat capacity and specific latent heat into this and derive a mathematical value for the change in the internal energy of a substance. So the equation to work out the change in the kinetic energy of all the particles is equal to E equals mc triangle T, where m is equal to the mass in kilograms, c is equal to the specific heat capacity in joules per kilogram degree Celsius, and triangle or delta T is equal to the change of temperature in degrees Celsius, whilst the change in the potential energy store of all the particles is equal to m times by L, where m is the mass in kilograms and L is the specific latent heat in joules per kilogram. So the equation on the left is the equation to work out the energy transferred into or out of a substance when the temperature changes, whilst the equation on the right is the equation needed to work out the energy transferred into or out of a substance when it changes state. So now these equations are given to you in your examination on the equation sheet, but for higher tier examinations it will be likely you'll be asked to rearrange these equations. So that's a very, very important idea. Now, important, as we mentioned before, is the idea that we can identify the state change or the change of temperature from a heating or cooling curve. Now you'll notice on a heating or cooling curve there is actually two state changes. There's the melting and the freezing transition, and there's the boiling and the condensing transition. Now the energy per kilogram needed to change the state from a solid to a liquid, which is either going to be melting or freezing, is called the specific latent heat of fusion, whilst the energy per kilogram needed to change the state from a liquid to a gas or vice versa in either boiling or condensing is the specific latent heat of vaporization. Now it's important to note that the specific latent heat of vaporization is always larger than the specific latent heat of fusion for a substance. This is because there's a greater change in the forces of attraction going from a liquid to a gas and vice versa than going from a solid to a liquid and vice versa. But let's now look at some of these equations in action. So you could be asked to calculate the change in the kinetic energy store in this particular example. So a 4 kilogram piece of lead is heated by 20 degrees. The specific heat capacity of lead is 128 joules per kilogram degrees Celsius. What is the change in the internal energy of the object? Well, we're changing the temperature, so we've got to use the equation E equals mc triangle T. And we're just going to check obviously our mass is in kilograms before we place it into the equation. Step 2, you substitute the values into your equation. That tells the examiner that you know what the mass is, you know what the heat capacity is, and you know what the change of temperature is. You then calculate your answer by timesing those values together. Then you put a unit on the answer and write this to the correct number of significant figures. Now in the question, you give it to the same number of significant figures as the smallest one given to a value in the question. So you look at this question and it's 4.0, 20 and 128. So you could argue it's either one significant figure or two significant figures in your answer. Another example would be a 6 kilogram piece of lead is heated from 10 degrees to 40 degrees. The specific heat capacity of lead is 128 joules per kilogram degrees Celsius. What is the change to the internal energy of the object? Well, because we're changing temperature, we're going to use the equation E is equal to mc triangle T. Now you place the values into the equation, so you substitute it in. Now no, triangle T or delta T means change in temperature. So if it's going from 10 to 40, the change is going to be 30. You put the values in, you times them all together, you calculate an answer, then you put a unit on your answer, it's joules because it's energy, and we write this answer to the correct number of significant figures. And you look in the question, 6.0, 10, 40 and 128. You can either have one or two significant figures in your answer there. So we get an answer of 23,000 joules. And finally, a 20 kilogram block of ice is melted. The latent heat diffusion of ice is 330,000 joules per kilogram. What is the change to the internal energy of the object? Now in this instance, our equation is looking at melting, a state change. So it's E equals ml. You place the values into the equation by substitution. You calculate your answer. You put a unit on your answer and write it to the correct number of significant figures. So just to clarify, every object is a store of internal energy. Every object is made from particles. There's an attraction between the particles to produce a potential energy store. There's movement of the particles to produce a kinetic energy store. And together the kinetic and the potential energy store of all the particles gives the internal energy. So increasing the temperature of the substance can be carried out by placing work into the substance. This increases the kinetic energy store of the substance and increases the internal energy of the substance. So the change in the kinetic energy store is given by the specific heat capacity equation. E equals m times by c times by change in T. Now remember, another name for the kinetic energy store of the internal energy is the thermal energy of the object. Now this concept has been covered previously in the GCSE Physics Energy module. Now again, change in the state of matter. So for example, going from solid ice to liquid water can increase the potential energy of the substance if work is placed into the substance, or decrease the potential energy of the substance if work is taken out. So this will either increase or decrease the internal energy of the substance. Now the change in the potential energy store is given by the specific latent heat equation. Now that equation is equal to the change in potential energy store is equal to the mass times by the specific latent heat. Now this is a new concept in GCSE physics which will be a focus for the upcoming parts of this course. So just to clarify, latent heat is a physics concept which governs potential energy store change. The energy needed for the substance to change state is called the latent heat. When a change of state occurs, the energy supply changes the energy stored but not the temperature. Now the specific latent heat of a substance is the amount of energy required to change the state of 1 kilogram of a substance with no change in temperature. And we can work this out by saying E is equal to m mass times by L, the specific latent heat. And the specific latent heat of fusion is the energy needed to change the state from solid to liquid. The specific latent heat of vaporization is the energy needed to change the state from liquid to vapor. The latent heat of vaporization is larger than the latent heat of fusion. So to summarize what we've learned in today's lesson, we should know that Firstly, okay, that if the temperature of a substance increases, well then the increase in the temperature on the mass of the substance heat, it depends on the mass of the substance heated, the type of material, and the energy input to the system. E equals m times by c times by change of temperature. And the specific heat capacity of a substance is the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Now the specific latent heat of a substance is the amount of energy required to change the state of 1 kilogram of the substance with no change in temperature, where E is equal to ml. And you should know the specific latent heat of fusion is the change of state from a solid to a liquid, and the specific latent heat of vaporization, the change of state from a liquid to a vapor, and you can distinguish between specific heat capacity and specific latent heat. So in today's lesson, if we've been successful, we can observe how the internal energy of a system can be changed, we can describe how a substance can change internal energy, and we can calculate the change in the internal energy of a substance. I hope you've enjoyed today's lesson looking at the changes in the internal energy of a substance, which is found in the particle model of matter topic in GCSE Separate Science Physics. Thank you very much for listening to this lesson, and have a lovely day.